Hello, I want to show off something I've been working on. It's a way to get cheap buttons and get one button per player and to not use Bluetooth or Wi-Fi to communicate with the shared game timer, but instead to use a wired connection and then send keyboard commands from the microcontroller straight into the device so that you don't have to mess around with Bluetooth connections or Wi-Fi or anything like that. So it's immediate and pretty cool. So let me show how it works. So we have player 1 here. This is player 1's button. If I press it once,
player 2.
I end his turn. Now, this button only works for player 1, so if I press this button again, I'm not ending player 2's turn because player 2 is over here. So if I press once here,
player 4.
We ended the turn. Player 3 has passed, so we skipped that. We're on player 4 now. If player 4 wants to pass, he can double press the button.
Player 4 passed. Next up, player 1.
And we're back to player 1. Now, one cool thing about the fact that each player has a player-specific button is that if we have simultaneous turns...
Simultaneous turn started.
Now, everyone's time is running, and whenever someone wants to finish what they're doing, they can press the button, and in whatever order. So player 4, for example, might say that he's done with whatever is going on, so I just press the button once.
Player 4 is done.
And now they can all end in whatever order they want. So maybe player 2 is next.
Player 2 is done.
And then player 1.
Player 1 is done.
And finally player 3.
Simultaneous turn finished. Back to player 1.
Alright, cool. So that's how the buttons work. The only thing that's going on here with the microcontroller is that I plugged it in straight into the device. So the microcontroller is powered from the device, so I don't need an external power source. And it just acts as a keyboard, sending keyboard shortcuts to the device. The buttons are wired in. Each button has 2 wires. One that goes into ground, which is this line here. They're all connected to the same thing. And then the other wire goes into one I/O port each. And then there's a bit of code, which is super simple. And like I said, it just works. The challenge with this project, there's a little bit of soldering. Most of the time when you want to connect wires to microcontrollers, you'll have to do a bit of soldering. There are other ways of doing it, but soldering is the easiest. The other problem is, what are you going to do with all these wires? So these buttons came with a wire, but it's short. So these 2 buttons are just plugged straight in there. And then these buttons, which are further away, I use this very thin 4-wire wire, which then splits here, going into each of the buttons. Now, what are you going to do with all these wires? Well, one way of doing it is to raise the board game up using something. I'm using coasters, but if you have a 3D printer or something else, then you can lift it up with something else or use more coasters so that the wires have somewhere to run underneath the board without the board being wobbly. Or you can run the wires around the board, maybe preferably using some kind of wire management system like a rail or something, so that it's not there's no wires everywhere. So the main challenge about this project is a bit of soldering and then how to make it look pretty. But it's a very cost-effective way of getting lots of buttons. I think 10 of these buttons cost $10 on Amazon. A microcontroller that now it doesn't need to have Wi-Fi or Bluetooth capability, it will only set you back about $6. So you could get all of this working for like $20 with the wires and the breadboard and stuff. So that's pretty cool. And like I said, you just plug it in and it works out of the box. And that's it. If you are inspired by this and want to do something similar, just let me know. I'm always happy to help.